In this video, I'm going over the concept of differentiability and continuity given a graph. So when a function is differentiable, it of course must be continuous. However, the continuity also does not guarantee that it's differentiable at that x value. So the areas where a graph or a function is going to be where the derivative doesn't exist, it's not differentiable, is, well, of course, where it's discontinuous, right? So like you have your removable, a jump, you have an infinite. So those types of discontinuities. But there are also areas where if it's continuous, that it also is not differentiable, where there is no derivative. And that is where you have a cusp or a sharp point or a vertical tangent. So basically, if the graph is going down at a negative slope and then all of a sudden shoots up to a positive, this is what's called a cusp. Because remember, when we're taking the derivative here, we're getting that instantaneous slope. But if I were to draw a tangent line here, is it showing accuracy in terms of the slope of this line here, instantaneous slope? No, because like, for example, right now, this is showing 0, but that is not inaccurate here. So this is an example. That's what a cusp is. So basically, if you have that sharp turn or from both sides, you have that different slope coming from the both directions. So like here in this example, with our function, we'll go through and identify. So like, let's say we want to identify where it is discontinuous. Well, it's discontinuous at x is equal to 3, right? Because what do we have here? We have a removable discontinuity. Now, that's the only discontinuity that we have. However, does that mean that everywhere else on the function, all these other x values, it is differentiable? No. So we do have other special cases. So like, for example, at x is equal to -1. Notice how here you have a slope of 0 and then goes down to -1. So this is a cusp and not differentiable. So even though it's continuous, it is not differentiable at x is equal to -1. So then another value would be here at x is equal to 2. That is also a cusp because we have that slope of -1 and then now turn and making that steep slope here. So then what's another? We do have another cusp. Yep, right here at x is equal to 5. So again, not differentiable. Then we also have one other area where it is not differentiable. Right here at x is equal to 6. So notice how you have this section here. That is what we have, a vertical tangent. So here it is also not differentiable. So again, continuity doesn't mean automatically that it's going to be differentiable. So here, we'll do another example separating it as well. So we're talking about where it's not differentiable. So again, let's focus on the x values where it's not continuous, right? Because then that means it's not differentiable. Well, x is equal to -3. What do we have here? A removable. Do we have another type of discontinuity? Yes, right here at x is equal to 4. Now what do we have here? We have a jump. So now we have no other discontinuity. So does that mean we have other areas where it's not differentiable, but continuous? Yes, right here at x is equal to -2, we have a cusp. Notice that sharp turn here, so it's not differentiable. And where else? Right here at x is equal to 2, we also have a cusp. Everywhere else, all these other x values, according to this function, is differentiable. A derivative does exist. So here, There are two U tries, if you notice in the notes. Go ahead and, sorry about that, pause the video and try these two U tries on your own. And here we go. So X values where it is not continuous, you should have identified X is equal to 0, which has that hole, so removable. And you also had X is equal to 1. Right here, you should have seen a jump. Then, where it's continuous but still not differentiable, you should have noticed you had two cusps. There were two at X is equal to -2 right here, and X is equal to 3 right here. So then overall for the other U try, you just had to identify all X values where it's not differentiable and explain why. So here you should have seen that X is equal to -4 is discontinuous. You have a jump, so it's not differentiable. At X is equal to 0, you have a cusp. And at X is equal to 5, you also have a cusp. All other X values, the derivative exists.